All right, happy Monday, Algebra A. As you know, we've been reviewing 4.1 here for the last couple of weeks. Now we're going to jump into 4.2, so we're going to get into some new stuff today. There's a blank copy of these notes on Schoology, as well as this filled out copy here of this video. It says we're going through. Feel free to pause at any point to write things down and catch up, or if you need to rewind and go back, by all means, please do so. So what we're going to do today, we're going to start looking at solving systems with something called substitution. We've been doing graphing up until this point, but now we're going to use substitution, which is basically using our algebraic skills and equations. So you notice here they have this word problem set up in kind of Monopoly deal where they have 3 cars and $100 equals 1 house, and then down here 2 houses, a car, and $100 is 1 hotel. And so the diagram shows us that. It also tells us that a hotel is worth $2,400. So we know the numerical value here. And then it says, how much is a car worth? Explain your reasoning. And so based on what they've given us, we can do a little bit of a setup here. If we let x equal cars and y equal houses, this first equation here, we have 3 cars plus $100 equals 1 house. The second equation, we have 2 houses, 1 car, and $100 is 1 hotel. We know that a hotel is $2,400. So really I have 3 equations now, or 2 equations if I use x and y, and here they are. So 3 cars plus $100 equals a house. 2 houses plus a car plus $100 equals $2,400. We're going to come back to this at the end of this lesson and actually solve this for x and y. We're going to set some background first. So once you pause this until you have this down, then we'll continue to page 2, and then we'll come back to this at the very end. All right, so page 2 tells us that the substitution method is used for solving a system as an efficient method when one equation is already solved for a variable, or when one equation can be easily solved for a variable. So if you look at this first one here, y equals 3x, this is already solved for y. We know that y equals 3x, and because we know that, we can plug this 3x into the other equation. So that's our substitution piece, if you will. And so instead of y here, we're going to replace that with 3x. And what that does is that gives me x plus 3x equals 32. And we'll actually go this way. So I know that x plus 3x equals negative 32. I can combine these two together. That makes 4x. And then I can divide by 4 here, and I know that x equals negative 8. And now that I know what x equals, I'm going to plug this, I'm going to substitute that back into this top equation. So notice here the top equation was y equals 3x, and we replaced that x with negative 8. And so y is negative 24. And then our last step here, we have x and y. The last thing we do is we write those as an ordered pair. So always remember with a system, whether we're graphing or substitution or any other method, always write your answer as an ordered pair. So again, this one was already solved for y. We plugged that 3x in here for y into the bottom equation. That allowed us to solve once we had x. Plug it back into the top one, solve for y. And again, as you need to, feel free to pause at any time or rewind and go back through as you need to. Okay, this is a unique example to this lesson today in that this equation is not solved for x or y. And so that's basically what's telling us here. Sometimes we have to solve one of the equations for x or y. So we're going to pick this bottom one here. And we're going to pick the bottom one because it has 1y. If you notice the top one, we got 3x and 4y, so we don't want to mess with that. We're going to stick right here because we've got 1y. And if I add 2x to the other side, then I get here. I get y equals 2x plus 2. So I'll show why we have it circled in a minute. But if I add this 2x over, y equals 2x plus 2. Now I can plug that in here So I just brought this equation down. Now that I know what y equals, I can substitute it in there for y, like so. And so now I know, go back up here for a second, sorry about that. So now I plug this in for y, and now I can distribute and solve. And so when I distribute here, 4 times 2 is 8x, 4 times 2 is 8. I'll combine my like terms right there. 11x plus 8 equals 19. Subtract 8 from both sides, and then we divide by 11, and we know that x is 1. Now that I know what x equals, I can plug it back into this equation, and that's what you're going to see here. So I plugged 1 in for x in this equation, and 2 times 1 will be 2, giving us y equals 4. And now I'll move this out of the way here. Oh, and oh, there it is. And I almost broke rule 1 there. We got to make sure we write our ordered pair. So x is 1. Plug it back in here. Y is 4. So our last step again, write your ordered pair. Okay, 3 and 4. These two examples are very similar. If you look at both of these equations in number 3, they're both solved for y. So I got y equals negative x plus 3, y equals x plus 1. Since both of these quantities equal y, they are equal to each other. So I can actually say that negative x plus 3 is equal to x plus 1. Again, I can say that because they're both equal to y. Now that I have that, now I can solve this. So first thing I'm going to do is add x to this other side here. Alright, so we added x to both sides. That's where this 2x came from. Then I can subtract this 1 over. So 2 equals 2x. Divide by 2, and we know that x is 1. Now that I know x is 1, I can plug it back into either one of these equations. It doesn't matter. I'm going to use the bottom one just because it's less work, but you can pick either one at that point. So I'm going to plug 1 into the bottom equation for x, and y is 2. And again, we always finish by writing our ordered pair. You'll notice these two equations, the same thing happens. They're both equal to y. Because they're both equal to y, then we can set them equal to each other. And so that's where we'll start. 2x plus 2 equal to 4x plus 6. I'll subtract 2x from both sides. And that gets me right here. Then I will subtract 6 back over. And my last step is to divide by 2, and I know that x is negative 2. Again, now that I know x, I have the choice. I can plug it into the top one or the bottom one. Doesn't matter. That's your choice. I just plugged into the top one. And 2 times negative 2 is negative 4. And so when all is said and done, y is equal to 2. And so again, once you have x and y, write your final answer as an ordered pair. Okay, our next two examples, very similar. Notice number 5 is already solved for x. So I know that x is negative 2y plus 4. So I'm going to substitute this quantity in right there for x. And something unique is going to happen when we do that. When I distribute, I get negative 4y plus 8 plus the 4y that was already there equal to 8. And so what happens, these y terms are opposites. They cancel out, and I get 8 equal to 8. And anytime the variables cancel out and you get a numerical statement that's true, we know from earlier in the year, that means that you have infinitely many solutions. We also write this as IMS, so if you want to shorthand that and write it as IMS, you certainly can. But I plug this value in for x. When I distributed, the y terms canceled out, and as a result of that, 8 equals 8, infinitely many solutions. Here, we know that y is 3x minus 11, so I'm going to plug that in right there for y. And again, this is going to be very similar to the last one over here. Notice the 3x's cancel out, And this time we get an untrue statement. Negative 11 does not equal negative 13. And when that happens, we end up with no solution. So if the variables cancel out and you get a true statement, it's IMS, or infinitely many. When it cancels out and it's not equal, no solution. All right, almost done here, I promise. As we mentioned at the start, when we were looking at that first slide, we're going to come back to that. So that's what I'm going to do right now. And where we left off was right here. We had our two equations. So you should have all this stuff right here with x and y. We had our two equations. And what I'm going to do here, you can see this is solved for y. So I'm going to put 3x plus 100 into this equation for y. So I'm going to scroll down so you can see that. And so as I do that now, when I distribute, this equation is all in terms of x, and I can solve for x, which is going to be 300. Once I have x, so again, I plug y in here, solve for x. X is 300. Now I can plug that back into this top one, and I can solve that for y. Y is going to be $1,000. So our last step, write it as an ordered pair, $300 for a car, $100 for a hotel, or excuse me, for a house. So $300 for a car, $1,000 for a house, and that is our solution to our intro problem. All right, so this concludes the notes for part 1. This will correspond with homework day 1 from 4.2, and we'll talk to you later. Thanks.